Hello, I am Paromita. I am pursuing PhD at IIT Kanpur and I am from Department of Physics. Now we solve problem number 2 from assignment number 1. So, assignment 1, problem number 2, and this problem is taken from Professor Harbola's book. So, as I told you earlier, you should solve all assignment problems, solve all example problems in that book, and you should also solve all the exercise problem. If you solve many problems, the understanding will be clear. So, let us start the second problem. The second problem says that there are two vectors A and a vector, say this one. So, this is vector A and this is a vector B. So, it is given that A plus B magnitude is equal to the magnitude of the vector A minus B. Please recall from your week 1 lecture series that how we add or subtract two vectors. When we add two vectors, we take the first vector and on top of that vector we put the tail of the other vector. So, this is my A vector. So, I draw the A vector and this was my B vector. So, on top of A I draw the second vector which is B, right, and A plus B will be this, right. Similarly, if I want to take a vector A minus B, that is a subtraction between these two vectors, how will I do it? So, it is nothing but writing this vector as A plus of minus B. So, if I know the vector B, minus B will be this. So, this is B vector, this is minus B vector, it has the same magnitude but opposite direction. So, if I have vector B like this, I can draw here minus B with the same magnitude as B but in the opposite direction. So, this is my minus B vector, right, and this is A. So, let us take a little bit magnitudes to be same. So, suppose this is my B vector. So, this is my A minus B. Okay. So, now if I take A to be AX along I cap. So, this is the coordinate system I am taking. This is X, or I call it, this is my X axis, this is my Y axis and this is my Z axis. So, the unit vector along X is I, unit vector along Y is J and unit vector along Y is K. So, now I have this vector A like this. So, the component of this vector A along X, Y, Z is AXI, AYJ plus AZK. Similarly, for the vector B, I can write it as BXI, BYJ plus BZK, and I can take the B vector as, say this. I have already taken the B vector like some other direction. So, let us continue with that direction only. So, B was like this. So, let me take that. Yeah, it's almost okay. So, B was like this. So, this is my B. So, now if I add this to vector, what will be my A plus B? So, it would be AX plus BX along I, that is along X direction, then AY plus BYJ plus AZ plus BZ along K. and if I take A minus B, what would be that? Which is nothing but A added with minus B, like this, A added with minus B. So that is nothing but AX minus BX I plus AY minus BY J plus AZ minus BZ. Okay. Now I obtained all the components for A plus B and A minus B vector. So if I now take A plus B vector is equal to C vector and A minus B vector is equal to D vector, then what is the magnitude of C? That is the magnitude of A plus B vector, and which is nothing but, you can see from here. So this is the A plus B vector, this I call C, and this is the A minus B vector which I call as D. So this will be root over of AX plus BX square, AY plus BY square, AZ plus BZ square whole root. Similarly, the magnitude of the D vector, which is nothing but the magnitude of A minus B vector, which will be, from the previous page you can see that it was this, right. So I can just write the magnitude of this vector as AX minus BX square plus AY minus BY square plus AZ minus BZ square. In the given equation, in the given question, we can see A plus B mod equal to C equal to A minus B mod equal to D, right. So these two are equal. So I can just square it and I write it as AX square plus BX square plus twice AX BX plus AY square plus BY square plus twice AY BY plus, from the third term I can get, this is just A plus B whole square. So I can get X S square plus B square plus twice AB. So I get AZ square plus BZ square plus twice AZ BZ, and from the right hand side I can get this the square of this quantity. So this is AX square plus BX square minus twice AX BX plus AY square plus BY square minus 2AY BY plus AZ square plus BZ square minus 2AZ BZ. So if I just cancel the same term from both sides, I get AY BY square all are cancelled, AZ square cancelled, BZ square cancelled. So I am left with this, 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 this and this. So let me write it down again. I get from the left hand side 2AX BX plus 2AY BY plus 2AZ BZ, which is equal to minus 2AX BX minus 2AY BY minus 2AZ BZ. If I take everything left hand side, so I will get 4AX BX plus AY BY plus AZ BZ, which is equal to 0. Now this is nothing but 4 A dot B is 0 or A dot B is 0. So the dot product between the two vector A and B is 0. So A is perpendicular to B. So this is what we wanted to see. So if the two vectors, so we see that the dot product between the two vectors A and B is 0. So dot product between two vector is mod A, mod B, cosine of the angle between them, let's call it theta, is 0, and mod A is not equal to 0 and mod B is not equal to 0. The magnitude of the two vector is not 0. So the only possibility is cosine of theta is equal to 0, or cosine of theta is cosine of 2n plus 1 pi by 2, where n equal to 0, 1, 2, 3 and so on. So you can see that if n equal to 0, then I get cosine theta is equal to cosine of pi by 2 or theta equal to pi by 2. For n equal to 1, I get theta equal to 3 pi by 2. For n equal to 2, I get theta equal to 5 pi by 2 and so on. So I can just write that angle between A and B is pi by 2. So the two vectors A and B are at angle pi by 2 from each other. So vector A is perpendicular to vector B. So that solves the second problem. Now we start with problem number 5 in assignment number 1. This problem is taken from Professor M.K. Harbola's book. So the problem is such that we have two concentric circles. So center is at O. So now I have the y axis like this and the x axis is like this. At time t equal to 0, a particle, say B, is here and a particle, say A, is here. So they start from the y axis. Okay. So they move at time t equal to t greater than t. So the particle A starts moving clockwise and the particle B starts moving anti-clockwise. So at a time t greater than 0, say t1, A is here. This is the new position of A at an angle theta, and B is here. This is the new position of B at time t greater than 0, say t1. Now the thing which is supplied is that they are moving with the same angular speed, but A is moving clockwise and B is moving anti-clockwise. So I can write the angular speed, same angular speed omega. Now at any time t greater than 0, particle A will reach here. So I can see this is the R1, this is the radius of the first circle, this is R1, and the radius of the bigger circle is R2. So R2 is greater than R1. So the radius vector R1 at any given time t is this, and the vector R2 at a given time t is this. So I can see from here that if the angular speed omega is same, I can write the angle or the angular displacement theta is omega t. So I write the radius vector R1 component wise as this. So this is R1 along x, unit vector x, plus R1, the component of R1 along y, which is R1 y, unit vector y. Similarly for the R2, which is the radius vector of the particle B, so this is R2 is equal to R2xx plus R2 y y. And how will these values change? So R1 I can write as, you see from the diagram that R1 is making an angle theta with the y axis, with the positive y axis, and R2 is making an angle, the same angle theta with the positive x axis. Why it is making the same angle with the positive x axis, positive y axis, is this because the angular speed is the same for both the particles. So now I can just write the R1 sin theta x. Why it is positive? Because you can see that the component of R1 along positive x axis will give me a positive value for this. So I get R1 cosine theta x plus the component of R1 along the positive y axis will be R1 cosine theta y. For R2 I can write, you can see this is negative x axis. According to my chosen coordinate. So this is negative x axis. So the component of R2 along x axis will be minus R2 sin theta, because the angle it makes with the y axis is theta. So this is sin theta. So minus R2 sin theta x, and the component of R2 along the positive y axis is R2 cosine theta. So I write it as R2 cosine theta y. So you can see that at a time, say t equal to t prime, this is my x, this is my y, this is a smaller circle. So this is the smaller circle with a radius of R1, and this radius is R2, and this is the origin. So my A particle is right here and B is say right here, both moving with the same angular speed. This is clockwise and this is anti-clockwise. So I have the area OAB is like this. So this is O, this is the position of B, this is position of A. So I have this OAB. Now the question is, at what time t greater than 0 this area OAB will be maximum. Let us first write the expression for area OAB. So what would be OAB? Area of OAB is half the magnitude of the vector R1 and vector R2. If you see from what we have drawn before, this is the R1 vector and this is the R2 vector. So we can just complete the parallelogram like this, and we would see that area of that parallelogram will be R1 cross R2 magnitude, because R1 or R2 are the two adjacent sides of a parallelogram, and you have learned from the lecture notes that this is the way we calculate the area of a parallelogram. So the area of this OAB, the triangle, will be half of that area. So it would be half of R1 cross R2. R1 and R2 are the two adjacent sides of the area OAB. So now I need to find out the area of the triangle, which is half of R1 cross R2. So I know the cross product between two vectors R1 and R2 in this case is written like this. You can see the components from the previous page that I have written R1 to be R1 sin theta plus R1 cos theta, and for R2 I have written it as minus R2 sin theta and R2 cos theta, and that is quite evident from the picture that we have drawn. So now I am writing it as r1 sin theta and r1 cos theta. So r1 sin theta. Now you can see that theta is now a function of time, because theta is omega t. Depending on the time, theta will increase or decrease. So theta is now a function of time. So I write sin theta t. Theta is a function of time, and then I get here r1 cosine theta as a function of time. For r2, I know this is r2 sin theta with a negative sign and r2 cosine theta t, and the z component to be 0. Now I can write it as I times 0, j times 0 and k times r1 r2 sin theta t cos theta t, and I will get another from here. So I get 2 r1 r2 sin theta t cos theta t. So this is the value of r1 cross r2. So r1 cross r2, as we get from the previous line, was 2 r1 r2 sin theta t cosine theta t. Why I am writing cosine theta t sin theta t? Because theta is not a constant, but it is a function of time. So now I know the area. Let us call it A. Area A is the area of OAB, which is half of this area, the magnitude of r1 cross r2. I should give this is a vector, so I am writing it as this. So this is along the k direction. So now I get this and I write it as half. The magnitude of this will be 2 r1 r2 sin theta t cosine theta t, or I write it as half. 2 sin theta cos theta is 2 sin theta cosine theta is sine of 2 theta. So I write it as r1 r2 sine of theta t 2 theta t, and you know that we have shown before that theta t is omega t. Using that, I write this as half r1 r2 sine of 2 omega t. Now for the area to be maximum or minimum, we need to find out the time t equal to say t1 at which this area becomes maximum. So for that we need to take the derivative of the area with respect to time, and then we have to equate it to 0. So if I get the area like this, now I have to take the derivative of this area with respect to time, and equating it to 0 will give me the maximum or minimum of area. So to get the maximum, we need to take the double derivative of this area with respect to time and have to check whether this value is negative or positive. If it is negative, then it is a maximum. Let us first do this thing. We find the dA dt and then equate it to 0. So A is, so now we will find out the time at which the triangle OAB will have maximum area. So the expression that we get for area of OAB was half r1 r2 and sine of 2 omega t, because the angular speed omega is same. Now we call it A, right? We call the area to be A. So now I take the time derivative of this area. So this gives me half r1 r2 2 omega cosine of 2 omega t. This has to be 0 to have maximum or minimum area. So I know that r1 not equal to 0. R2 is not equal to 0 because they are the radius of circle 1 and 2. So, omega is also non-zero because omega is the angular speed, so it is non-zero. So, the only possibility that this equation is 0 can come from this cosine of 2 omega t is equal to 0. And how we get this to be 0? This is cosine of 2n plus 1 pi by 2, where n is 0, 1, 2, 3, 4 and so on. So, now for n equal to say 0, what is this value? So, I get 2 omega t is pi by 2. For n equal to 1, I get 2 omega t is n is 1. So, this is 3, n is 1. So, I get 3. So, I get 3 pi by 2 and so on. So, let us take this value pi by 2. So, my 2 omega t is pi by 2, or the time t, I call the time at which this happens. So, I call this time as t1. So, at 2 omega t1 equal to pi by 2, I guess t1 is pi by 4 omega. So, this is the time at which the area A is maximum or minimum. Till now I do not know whether it will give me maximum or minimum. That I have to check from the double derivative of this area with respect to time. So, let us perform the double derivative of the area, which is d2a dt square, and that is double derivative of the area. So, the expression for area A was half r1 r2 sine of 2 omega t. So, this was half r1 r2, which are the radii of both the circles. So, and from here the derivative will give me 2 omega cosine of 2 omega t. Now, I have to take the second derivative with respect to time, and which will give me half r1 r2 2 omega. These are constant, so this will come out of this expression, and I can just write it as minus sine of 2 omega t and 2 omega. So, I get, so 2 cancels, I get r1 r2 2 omega square, a minus sign is there, so I write minus 2, and then I get sine of 2 omega t. So, this is the expression for the double derivative of the area A. So, now we see this is the expression for the double derivative of the area. Now, you can see from what we have obtained, d2a t square is minus 2 r1 r2 omega square sine of 2 omega t. Now, we have obtained that at time t1 equal to pi by 4 omega, the area is either maximum or minimum. So, the time we obtained before was pi by 4 omega, at which the area is maximum or minimum. So, let us taste whether at time t1 equal to pi by 4 omega, whether the area is maximum or minimum. So, we will put this time here. We see that the double derivative becomes minus 2 r1 r2 omega square sine of 2 omega, and I write time to be t1, which is sine of 2 omega, and t1 is pi by 4 omega. So, omega cancels, I get pi by 2. So, minus 2 r1 r2 omega square sine of pi by 2, and you know the value of sine of pi by 2 is 1. So, I am left with the double derivative value as minus 2 r1 r2 omega square. If you recall from what I have said earlier, that to check whether this gives me a maximum or minimum area, I need to check whether the double derivative is negative or positive. Here I am getting a negative number, so d2 dt square is maximum at t equal to pi by 4 omega. So you see this is a negative number because r1 is positive, r2 is also positive, and the square of the angular speed which is obviously positive. So I am having a negative number here. So this is maximum at t1 equal to pi by 4 omega. So this is the answer. So the answer is at t equal to pi by 4 omega, the area OAB that made by r1 and r2 vectors, which are the position at time t for particle A and particle B, and this is the center O. So this is the area. It would be maximum for t equal to pi by 4 omega. So this is the answer. With this, we finish the problems from assignment number 1.